Hello and welcome. Today we're going to explore all the display modes your VDG has to offer and exactly how to control them from assembly language. Some of the modes you cannot get to using T-mode and screen in BASIC. In the process, we are going to find another use for structs in assembly code and variables in assembly code, and the use of the keyboard to control the action while it's going on. Ooh. In order to control the display mode from the VDG, you have to do three things. The first thing is you have to set the screen buffer start address. Where is the data in memory? The second thing is to set the ASM control bits. This decides how large the buffer size will be. And then finally, you set the operating mode on the VDG. The first thing you have already seen in a previous video, so I am not going to cover it again. That just leaves these two things. So number 2, setting the ASM control bits looks like this. I have borrowed this and all of the information from the Laurence Tepolt book, which is what I found to be the most complete description of how everything works. I've seen this description in other places, but this book is a pretty complete description of a lot of the hardware on the CoCo as well as how you program an assembly language. So on the right, you see all of the display modes, and on the left, you see the bits that you need to set in order to access the display modes on the right. So for example, let's say you wanted to go into G3R, display mode G3R. That happens to have this buffer size, 3072. You need to set V2 to be on, V1 to be off, and V0 to be on. So the way that works is V0 is controlled by these two addresses, V1 and V2. So if you want a 0 in this bit, you would set FFC0. If you wanted a 1 in this bit, you would set FFC1. So this is very similar to how I talked about setting the buffer start address, where you just poke an address. It doesn't matter what you poke. It doesn't matter the value you poke in it. You just go and store something there, and just by tickling that address, that tells the ASM that that's the bit that you want, either 1 or 0. So for example, if we wanted to do G3R, I would store a value somewhere in FFC1, I would store a value somewhere in FFC2, and then I would store some other value in FFC5. So this determines the size of the buffer. What about the next step? The operating mode is determined by these bits in address FF22. So you decide which display mode you want, let's say G3R. Then that tells you these are the bits that you need to set. When you see a C, that can either be 0 or 1, and that determines the color set. So everything else will be the same, but the color palette will be different based on the C that you choose. If you see an X, that means it does not matter. You can put whatever value you want for that bit, and the results will be the same. So if I wanted to do G3R, I would want to set bits 1, 1, 0, 1, and let's say I wanted color set 1. Then I would want a 1 in that spot. So that's the value we have here, 1, 1, 0, 1, and then 1 for the color set, and then the rest we just fill with 0. We figure out what number that is, and we poke it into FF22, and that sets the operating mode. And that's it. Just make sure that the ASM control bits you set correlate with the operating mode you set. Otherwise, weird things might happen. So let's look at how these steps look like in code. So the first step is to set the screen buffer start address. So if you remember from our previous video, that simply involved poking the correct addresses so that the bits they would form would end up being the proper page that you wanted that buffer to start at. The assembly equivalent of that is just storing some register in that address. And it doesn't matter what's in A. I don't set A up beforehand. I just say, all right, A's got stuff. Doesn't matter what that stuff is. But let's do these three addresses, and then that will give us the start address that we want. So the next step is over here, setting the SAM control bits. So I have stored those control bits in a struct, which I'm going to show you a little bit later. And so I just grab whatever that address is out of the struct, and then again, whatever garbage is in A, that's what I store into that address. So these three bits, V0, V1, V2, get set here, and that determines the size of the buffer. So remember, step one was to set the start address of the buffer. This determines the size of the buffer. The final step is to set the actual operating mode to be active. So again, inside my struct, I have that magic value where I assemble the bits together to figure out the operating mode I want. So I grab it, I put it into A, and then I store A into that address, FF22. So that means that the heart of this whole program is really this struct. All of the values that we store in the struct are the data that control this whole app. If I just change the values in here, the whole program would behave differently. So the fields of my struct are here. I have a name, which is a string that tells me the name that relates to the operating mode for that entry. The buffer size, the 3 SAM bits, and then that finally assembled operating mode number to poke into FF22. So let's look at a few examples. VDG disp modes is the address where I'm storing the array of those structs. So the first element of that array of structs is right here. And then the next element is right here. So let's just take a look at this as an example. We start with the name. So we'll keep this in the same screen, the name. And then we have these 4 bytes. And so first we have the buffer size, 4 words. We have the buffer size, which is right here. This is the alphanumeric display mode, which is fairly small, smallest buffer size you're going to see. And then we have the 3 words for the SAM bits. So these are the 3 addresses we need to poke in order to get the buffer size proper. So you'll notice the buffer size is sort of being stored twice in 2 different ways. First here, just as a direct number of what the size is, and then here, which addresses in the SAM we need to poke to make it be hex 200. The reason is that our code is going to need to use this number in some places, and obviously our code needs to set the SAM, so we have it stored in these 2 different ways. And then the final byte is the operating mode, and so this is what we end up poking into FF22. So as we scroll down, we'll see there are a lot of operating modes. A lot of them. And a lot of the work in writing this program is simply filling out all of this data in this array of structs so that they're all encoded here. To help keep myself on track and to make sure I didn't make mistakes, I also transferred from Tepolt's book this table so I would have it handy to look at as I was filling out the struct, and I just kept it here because it's useful reference. So for a wider view on how this program works, let's go back out and take a look at main. I'm going to skip over some of this initialization stuff, and I'm just going to focus right now on the main loop. So at the top of the loop, I call that method you just saw, activate disp mode, and that will tell the VDG to actually activate whatever display mode is now current that we're looking at right now. Within that, we have this garbage screen loop, which fills the screen buffer with garbage. So this is how we're viewing a display mode, is seeing what it looks like when all the different bytes show up but in a completely random order. So within the loop, we're using Y to keep track of where we are in the buffer. So at the top, we just ask to see if we've hit the end, and if not, we just skip over here. But if we have reached the end, then we just wrap around to the beginning. Now that we know that Y is properly within the range, we call toRandomBytes, which you've seen in a previous video, and that gives us a nice word that we can store into the buffer. So we move Y along as we store it. I'm going to skip some of this other stuff for now, and I'm just going to come back down here to the bottom of the loop. So when it's time to go to the next display mode, we need to advance our variable VDG disp mode cur. So let's take a look at that variable. Just above where the struct is defined, I have a few variables, and one of them is this VDG disp mode cur. So think of this as a pointer that points inside the array of VDG disp mode infos, and this pointer tells us the current VDG display mode that we're showing. One of the things that I skipped from the initialization is initializing that variable. So I load X with the address of all of the data, and that therefore has X looking at the very first element of the array, and then I stick X into this variable. So this variable is set up to start pointing at the beginning. And then at the bottom of our loop, I'm ready to advance it to the next element. So I load X with wherever VDG disp mode cur is pointing, and then I advance X to the next element of the array by going by this amount, the size of the struct itself. I check to see if I'm out of bounds, if my X has reached the end of this array of structs. And if not, I continue on and do my loop. But if so, I wrap around. So that's the overall structure of how we go from mode to mode and how those modes get enacted. Now we're going to go into a little bit more detail, and I'm going to show you a feature that I haven't shown you before. So we start off on the alphanumeric display mode, and if I just hit the space bar, that advances me to the next mode. I hit it again. Third mode looks a lot like the first mode. We'll need to talk about that. And then continuing on, 5, 6. So some of these you'll recognize that BASIC lets you do. Some of these you'll be like, ooh, I don't remember being able to do that in BASIC. That's a lot of colors with some small dots. And now we're in the quote high-res graphic screens, but the low-res ends, hitting the space bar, hitting the space bar. I'll just keep on going until we get to the highest mode, which is this, I believe, and then we cycle around. So the other feature is if you hit the N key, that switches the display to tell you what the name of the current display mode is. So this is AI0. If I hit N again, it'll toggle. And when I'm looking at the name, the other screen continues behind the scenes. So keep track of like where the other screen is. It's just about at the top. I go here, go back, and you'll see it was just at the bottom. So if I kind of go back and forth, you'll see that it just continues on. If I stay on the name screen, I can continue to advance from the display mode to display mode. And then if I hit N again, it'll show me the actual display mode. So all that's happening in the background while I'm looking at the thing. So I can go back and forth, get up to the one that I want, and then check out the screen. So let's take a look and see how that was done. So we'll start with the variable section. Show name is the interesting variable. Think of it just as a Boolean, and if it's true, then we're supposed to be showing the name screen. Otherwise, we're supposed to be showing the current video display mode. The way it's actually implemented is 0 is false, and 255 is true. That lets me do a COM statement to do the complement and toggle back and forth. We talked about this already. That points into the array of structs to show the current display mode we're using. Haven't really talked about screen end yet. So what I'm going to do is go back to the display mode method and show how these two things get used. Activate display mode is that first method I showed you. This is the one that handles all the bit twiddling for the VDG and the SAM. I skipped over some stuff before, so let's be a little bit more complete. It actually does a few things. Not only does it twiddle those bits, it also decides to display the name screen if it's time to. And so it'll like flip back and forth between the current display mode and the name screen. The other thing it does is it will initialize the name screen each time we advance to the next display mode. So let's see how that works. On entry, there are two assumptions. The first assumption is that variable, that Boolean that I told you about, show name, is already initialized to be the correct value. So this method will obey that variable. And it also assumes, as we've talked about before, the VDG disp mode cur is pointing to the current display mode to show. So the first bit of instructions initialize that name screen to make sure it matches the display mode that's active. This does not mean we're going to show the name screen right now. This just means we're sort of setting it up. Either it's in the foreground or it's in the background. At the moment, we don't know yet. We're just making sure that we set it up. So we grab the current display mode, we find the name field from that display mode, and then that puts the null terminated string into X. And then we position Y to be part of the name screen buffer. You'll see that we're always starting at 400 for the name screen, and for the display modes that we show, they never start at hex 400. They're later in memory. So that means the name screen is always left untouched. Then we go ahead and we print that string wherever Y was pointing. So this is pointing somewhere in the middle of that screen. And then we get ready for the rest of the method. So we reload X to point to the current display mode, and then we ask the showName variable what we're supposed to do. So equal, meaning 0, meaning false, means we're just supposed to display the garbage screen, which is the stuff that I've shown you before. Otherwise, we fall through and show the name screen. So when we do the name screen, we have to set the buffer start address not to where we're supposed to for the display mode, but we set it to just 400. It's always 400 for the name. We then do a couple of things that work with both the name screen being active or the garbage screen being active. And to set up for that, we point X to be not the current display mode, but the very first display mode, which is the AI display mode. The common code is just setting the SAM control bits to specify the screen buffer size, and then actually setting up the VDG operating mode to be the thing we're pointing to. So sometimes this will be the current display mode that we're showing the random garbage on, and sometimes this will be the name screen, depending on whether that's what the user selected. Some code up here that I skipped is the code that actually sets the screen end variable. So what it does is it only runs in the case where we're only showing the video display mode that's current. We're not showing the name screen. And we get the buffer size out of the struct for the current display mode. We add it to where our screen is supposed to start. So this is not the hex 400, but this is, much later in memory that doesn't touch the name screen. And then that sum, we go ahead and store in the screen end variable. Screen end is used in the main loop, in the garbage screen loop, to compare Y with, to see if we've hit the end of the screen. And that's how we know whether we need to wrap around or not. So back at main, let's fill in some of those gaps that I skipped over before. In the initialization section, I clear showName. That means it'll be false. That means we're going to show the current display mode with the garbage filling it up. That's our first thing to show. Then we clear the name screen. So I'm going to go to clear screen. You've seen this in past videos. The important thing is it always works with the screen buffer starting at hex 400. So this doesn't do anything to the current display mode screens that we show. In fact, you may have noticed as we're filling it up with garbage, the latter half, the first time around, is usually just whatever happened to be in memory at the time. We didn't really clean it up beforehand. For the name screen, we do. We clean it up by sending spaces, the green on black spaces everywhere. Then the other thing you've seen before, tweak name strings. This is going to run through the names of all of the display modes and make sure that the lowercase letters show up properly as the green on black. And then you've seen this, we initialize X to point to the very beginning of the display mode array. We put X into the variable that marks the current display mode we're supposed to show, and we set Y to be the beginning of the screen buffer. This is the screen buffer relating to the display mode we're demonstrating, not the name screen. So we already went over all this stuff. Now let's take a look at polecat. So within the loop, every single time we iterate, so every time we poke 2 more bytes of garbage into the screen, we always check to see if the user is doing something. This gives the illusion of stuff running asynchronously or simultaneously, like while we're filling up the screen, let's also obey the user. But of course, nothing ever really happens at the same time on a single CPU. So we just, do little slices. So we do a little bit of this, and then we check the user's input to see if we need to do a little bit of that. So we go into polecat, and then we see if there's any keystroke at all. Equal, meaning there's nothing, means we just skip over the keystroke management and we go back up to the top. So if there's nothing new happening, we just keep going up and up and up and up. When a key has been detected, we just check to see if it's the N key for name or anything else. So if it is the N key, then we're going to do these instructions here, which toggle show name, and then go back up to the top. But when I say top, I mean all the way to the top. So this is where we change the display mode. So since we toggled name, this is now going to know to show the name screen. Otherwise, if it was not an N, then instead of showing the name screen, it's time to just advance the display mode. And this I already showed you. So this just goes to the next element of that array, and then we go back up to the top to enact that new display mode. So that covers the code, but I wanted to point out something that I think is kind of interesting. We are toggling between different screen buffers for the text screen, for the alphanumeric display mode in some cases. So let's say this is, the AI, and we're demonstrating the AI. I go to the name screen. This is also the AI display mode. We're just using a different buffer. So this buffer gets to do its thing in the background while I flip to the name screen. So you've probably seen code that will do this sort of thing with the graphics screen. So it'll sort of create an animation with the high-res graphics screen. In fact, I have a video on my channel using BASIC that animates some designs by changing the step size, and it uses pmode 4.1 and pmode 4.5, so you have that off-screen buffer to draw the next frame, and then you can switch to it. But I don't think I've seen many people do that with text screens. And text screens are so small, you can have a lot of buffers. They're only hex 200 long. So you could make a whole bunch of these, do some kind of text-based animation, and flip between a whole bunch of them. So I think that's kind of interesting. Otherwise, let's go into turbo mode. And let's just take our tour.